Section 9 is the very last section in Unit 7B. And in 7B, you are going to be asked to find some solutions. You're going to solve for what theta could be. And the first thing that we had to write down is this. If you see something greater than 0, what that means is it has to be a positive value. Anything greater than 0 means we're looking for positive values. And so the problems that you're going to have will look like this. And you're going to have to figure out where, in what quadrants, will this be greater than 0. And so if you see greater than 0, I want you to think of where it's positive. I abbreviate things, but if you don't know what it means, when I put the plus sign there, I'm saying where it's positive. And then this is greater than. Anything greater than 0 is a positive value. Anything less than 0 is a negative value. So the reason why I have you start with that is because you're going to be asked, identify the possible quadrant or quadrants in which the terminating ray for theta could lie. Whenever you see this little extra s in parentheses, means it might be one quadrant or it might be more than one quadrant. So with that being said, sometimes when you see this, you go, I wonder if there are two. You should be questioning that. And we'll go down. Let's do 2 examples, and I'll show you what I mean. Number 3 is in your worksheet. You feel free to do this on your worksheet if you would like. The tangent of theta is greater than 0. We need to find where the tangent of an angle is positive. That's what we need to find. And so if you're thinking of the 4 quadrants, you can do this in one of several ways. Some of you will do this in terms of x and y. Your x or your C and S, C and S, C and S, C and S. Some of you will think of it like this. Positive, positive, negative, positive, negative, negative, positive, negative. Some of you will think of it like that. Some of you will think of it like this. All students take calculus. What we're looking for is where is the tangent positive. If you are the first method, the x and y person, you're looking for where is the tangent, where is the sine divided by cosine equal to a positive. Do you know which quadrants it is? If you know the quadrant or quadrants where the tangent is positive, tell the person you're sitting next to, please.
Yeah, I agree.
If you and your partner came up with quadrants 1 and 3, please raise your hand. Good job. That is most of my class. That is the correct answer. If you did not come up with 1 and 3, all of them are greater than 0. All of them are positive here, including tangent. A positive divided by a positive is a positive. And a negative divided by a negative is equal to a positive. Tangent and its cousin are positive in quadrant 3. 1 and 3 are the correct answers. Now it asks for the terminating ray. The terminating ray means where is this possible, where is it possible to end at? And we know that the tangent is only positive in those 2 places, so it could only be here or here, somewhere in that quadrant or somewhere in that quadrant. Cosine squared of theta being greater than 0. Where would the cosine squared be a positive value? Do you know which quadrants it could be in? If you think you know, tell the person you're sitting next to.
If it's squared, then actually, couldn't it be any of them? Because if you square a negative, it's still going to be positive.
I cannot tell based off of what I've heard from the general group if you guys all got the same answer, but I definitely feel like I didn't hear as much. I heard more indecision out of you. So let's go back to this, what this thing says. Is it asking for where theta could be, or is it asking where is this going to end? What does that mean? The terminating ray. Are we asking where theta is, where the angles could be? Are we asking where it's going to end? Terminating ray. Where is the angle going to terminate? Where is the angle going to finish? Where is the angle going to be positive for this cosine squared? When you square something, what do you know about a negative times a negative? And what do you know about a positive times a positive? What do those become when you square something? So what does that mean? We're looking for a value that is going to end up being positive. So my question to you is, how many of you said quadrants 1 and 4? Please raise your hand so I could see who got it correct. That was a lot less than I thought. That's less than 50%. The correct answer is quadrants 1 and 4. How come? Because cosine will only end up being positive when you square cosine. When you do a cosine of theta times a cosine of theta. And it's supposed to be greater than 0 or a positive value. The only places where cosine is going to be positive are here. But what if the angle was negative? If it was negative, a negative times a negative still equals a positive. It can still only terminate or be in quadrants 1 and 4. It's the only places that will be greater than 0. There's no way to get that thing times itself equaling the negative side. We're not asking about theta. We're asking about where it ends, which will be different than what we write down below. Okay? I'm hoping this makes sense to you. Do you have any questions on why 7 is quadrants 1 and 4? Raise your hand if you do. Okay, so we'll go ahead and you guys are going to get some practice with that. The other things that we wrote down in our notes are solving for theta means you are finding an angle that is on the unit circle that has the given ratio. That's what we're going to spend the majority of our time doing. Usually there are 2 answers. Now notice I said usually. That means that there is a possibility of having one answer. And there is even a possibility of having no answer, something that's undefined. Okay? So if I think of the unit circle like this, most of the time, if you think of things going this way or this way, it's going to have 2 solutions because it's hitting the unit circle in 2 different spots. But there is the possibility of having one solution if you hit the very edge of the circle, or one solution if you hit the top of the circle or the bottom of the circle. But if you're way off and you don't hit the unit circle at all, you could have no solutions. I say that, that's why I say usually. For most of what you're doing today, I want to say every single one has 2 answers. But if you're thinking about what we're going to do in Math 3 and Math 3 Honors next year for you guys, I want to let you know there is the possibility of having one answer or no answers, and that's something you're going to explore in next year's math class. Okay? Why are there usually 2 answers? Because there are 2 quadrants where trig functions are positive and negative. Sometimes you're going to be finding where the sign is positive, and there are 2 places where the sign is positive. Sometimes there's 2 places where the cosine is negative, or tangent for that matter. Second thing that we wrote down, when square rooting a variable squared, it is the same as the absolute value of the variable. I write that because that's the definition. They'll use that a lot in Math 3 Honors. So therefore, it should always be a plus or minus when solving a trig function squared. When we deal with solving something that looks like number 7, when you're square rooting something, don't forget when you square root something squared, don't forget that plus or minus sign. There's 2 possibilities with it. Keep that in mind. And why the definition is based off of absolute value, something that we'll encounter. The last thing, when a product is equal to 0, you can use the zero product property. We covered this in section 1. In unit 1 in the first semester, we talked about the zero product property. It's where you set the factors equal to 0 to solve for solutions, which is something we're going to use in the problems below. So I have one example from problems 11 through 14, and I have 2 examples for problems 15 through 21. If you want to do these in your worksheet or on your worksheet, you're welcome to do so. Let's start with number 12. The first thing I'm going to point out to you is it tells you solve for all values of theta. We're finding an angle that's somewhere between 0 and 360 degrees. Notice it's not equal to 360. And we're going to give all answers in degrees. That's what we're doing for numbers 11 through 14. So if I'm doing this problem, number 12, 2 cosine of theta plus 1 equals 0, here's what you'll do. I would subtract 1 to both sides. Draw a line. Two cosine of theta is equal to negative 1. We're going to attempt to get the cosine of theta by itself. Then what I would do is since 2 is multiplying cosine of theta, I would divide by 2. So now the cosine of theta is equal to a negative 1/2. And then this is where you will have to use your knowledge of the unit circle and figure out if there's one answer, 2 answers, no answers, or so on. The cosine of an angle is equal to negative 1/2. What I do personally is I start thinking in terms of the 4 quadrants. This cosine is negative. And I think of, where is the cosine negative? What are my possibilities? The cosine is negative where? In which quadrants? Do you know? 2 and 3. So what I would do is I would go, there's a possibility of a cosine being negative here, and there's a possibility of a cosine being negative here. My 2 terminating rays must be in quadrants 2 and 3 because that's the place where cosine is negative. If this was a positive 1/2, I would draw it in 1 and 4. Now what I have to do is I have to figure out what could the angle be in degrees that would give me a ratio of 1/2. And the hint that I would give you is that I use the unit circle and I use my hand trick all the time. So I'm going, which one has a cosine that's equal to 1/2? And I go like this with my hand. And I go, I need a cosine. Cosine's on, that's not it. That's not it. The cosine is on the left, square root fingers over 2. Oh, it must be this reference angle. And then I have to know in degrees how many degrees this finger is. The finger that I have down is how many degrees? Okay, I'm just going to write 60 degrees is my reference angle. But that would be my quadrant 1 possibility. In order for me to find the quadrant 2 possibility, the quadrant 3 possibility, I take that reference angle and I know it has something to do with 180 degrees that would put me into quadrant 2 and would put me into quadrant 3. The 2 possibilities. If you know what the 2 possibilities are, please tell your partner what it is and how you got the 2 possibilities. Discuss.
I think it might be, one could be 120 because, wait, never mind. That's 30, maybe 60 degrees. Because you're trying to get from this one to this one, right? And this one to this one.
I'm going to write it down and let's see how many of you got it correct. There are two answers. The two answers you should have come up with are 120 degrees and 240 degrees. If you came up with those two answers, please raise your hand so I can see how many got it right. I'm going to say 60 to 70% of my class got it correct. Okay, perfect. Put your hands down. If you did not come up with those two answers, let's talk about it. The cosine ratio we knew had a 60-degree reference angle. So that must mean the x-coordinate is going to be the same. The x-coordinate is going to be the same. We want the x-coordinate to be negative 1/2, and so if I know this is 180 degrees and I'm trying to find that angle, I should just do 180 minus 60 and then 180 plus 60. Those two possibilities are what I got in my solution, or as my solutions. My solutions are that if I did the cosine of 120 degrees, I would have gotten negative 1/2. And if I would have done the cosine of 240 degrees, I would have also gotten negative 1/2. That's how this section works. You have to find the angle that gives you the ratio. And a lot of times it goes right back to that reference angle that we were talking about at the beginning. So if you don't know theta prime or reference angles, that's what's going to make this part difficult for you. Questions on number 12, things you're still unclear on. I'm hoping that as we do the next problem, more of you will get it correct. That was number 12. Number 15 through 21, guess what we have to do that's different? Now we have to use radians. And there's a squared term in it. So we're going to have to do a couple things differently, which is why I have chosen 17 and 21. But let's just go ahead and work this out. I'm going to use the same method that I did before, even though there are two ways you could do this. I'm going to add 1 to the other side. I'm going to divide by 4 because 4 is multiplying. I'm going to do the opposite of multiply. I'm going to divide. And we wrote a note to ourselves. When square rooting a variable squared, it is the same as the absolute value of the variable. Therefore, it should always be a positive or a negative value. In order to get sine of theta by itself, we have to get rid of this little square. The opposite of squaring is square rooting. When you square root a trig function squared, that is the same thing as the absolute value. I'm just going to show that to you because you will use that a lot in Math 3. I'm going to use it right here. Now when I do the square root of 1/4, I'm technically square rooting 1 and I'm square rooting 4, which is 1/2. But because this is the same thing as the absolute value, what I'm going to do is I'm going to do the sine of theta is either equal to a positive 1/2 or there's that negative possibility as well. If you want, most math teachers will allow you to go from this square root directly into the plus or minus, the positive possibility and the negative possibility. But in Math 3 Honors, they're going to want you to see this definition of absolute value being the same thing as something, as the square root of something squared. Now what this does is this means that we're going to have more than one possibility. We are going to have 4 possible answers for number 17. How come? Let's just draw a quick thing right here. Where is the sign positive? What quadrants is the sign positive in? I'll put S is positive and S is positive. So I have those possibilities. And is the sine of theta also equal to a negative 1 over 2? So those are in quadrants 3 and 4. So guess what? This answer is going to have 4 answers. And every single answer will be based off of, in radians, the same reference angle. A reference angle that will give you a sine ratio of 1 over 2. There are 4 answers. With your partner, in radians, what are the 4 answers? Please discuss.
Do you want to get this is pi over 6.
The 4 answers that I have that I had to squish in here for whatever reason. I got pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. If you got those 4 answers, please raise your hand so I can see how many got it correct. I'm going to go 50% is what I see. 50% of the students. That's not great. So let's talk about it. Radians are maybe a hindrance to you. Let's see. Technically, it's a 30-degree angle that has a sine value of 1 over 2. This is also pi over 6. If you think that pi over 6 is the reference angle, think in terms of pi. And think in terms of 2 pi. If I'm talking about pi, it's a lot easier for me to think of pi radians as 6 pi over 6. 6 pi over 6 is the same thing as pi, but it's in the same denominator. So then you go from here all the way to here is 6 pi over 6. And I want to get to there, and this is pi over 6. What would you do? You subtract 1 pi over 6 from 6 pi over 6. Guess what you get? And then you go pi over 6 past 6 pi over 6. What do? You add this to the 6 pi over 6. What do you get? And then you have this 2 pi. If I think in terms of pi over 6's, that's the same thing as 12 pi over 6. And if you have pi over 6 short of 12 pi over 6, what does that make your last angle that would give you that same ratio? It goes back to, do you remember how to find all the reference angles and use the reference angles to find other values on the unit circle? Questions on 17? Then the last one that we're going to do is number 21. 21 has the product of the tangent of theta plus root 3 times the product is multiplied by the tangent of theta minus 1, and it equals 0. So what I see with this is, since it's multiplying to equal 0, I can use that 0 product property to set each factor equal to 0 and to solve for its solution. So what does that mean? That means this times this equals 0. Then by the definition of the 0 product property, either this factor has to equal 0, or this factor has to equal 0. The first one does, or the second one does. Otherwise, it would never multiply to equal 0. That's how it works. There's only two possibilities. Either this tangent of theta plus root 3 should equal 0, or the tangent of theta minus 1 is equal to 0. I'm going to put an or right there. It's either this has to equal 0 or that has to equal 0. And we're going to solve each one of those separately. We're going to set this subtract root 3 for the first possibility. And let's see what we have. The tangent of theta is equal to negative root 3. In my other possibility, the tangent of theta is equal to a positive 1. In these two possibilities, this possibility, I know that the tangent is going to equal a negative. Do you know which quadrants that has to be in? Where the tangent's negative? What quadrants where the tangent is negative? Okay. Oh, I'm sorry, Mr. Paramo. They said 2 and 4, Mr. Paramo. There you go. That's 2 and 4, not 2 and 3. So I need to find for this branch, for this first branch, I need to find an angle in radians that is going to give me a root 3 for my ratio. The first trick is I need a sine divided by cosine that's going to equal root 3. I'm a hand trick person, so I go like this and I go sine divided by cosine 1 over root 3. Well, that's not the same thing. That's not the same thing. Sine divided by cosine, it has to be this reference angle. In radians, this reference angle is that's my reference angle. I'm going to put equals theta prime. That's not what theta is. Theta is going to be the one that puts me into quadrant 2 and the one that puts me into quadrant 4. But I'm going to use that to figure out what the quadrant 2 possibility is. You're going to do something with pi to figure out the quadrant 2 possibility. You're going to do something with 2 pi. And most likely, since the denominator is a 3, you're going to do something with the 3 pi over 3 and maybe a 6 pi over 3, because that will help you to figure out what the 2 possibilities are. With your partner, discuss what the 2 possibilities for this branch are. Discuss, please.
So 3 pi over 3 minus pi over 3 is 2 pi over 3. 1 pi over 3 is 2 pi over 3 and 5 pi over 3.
Yeah.
So let me ask all of you to say it out loud to see if you got the quadrant 2 possibility correct. Let's talk about the quadrant 2 possibility. The angle in radians you got for the quadrant 2 was what? Say it out loud. That's a lot of you. Good. That's the quadrant 2 possibility. The quadrant 4 possibility. Say what angle you got out loud. A lot of you got that correct. Good. That is for this first branch. We still have this other branch that says the tangent of theta is equal to a positive 1. we still have to go, okay, tangent is positive in which quadrants? Hopefully you said 1 and 3. Or hopefully you were thinking that. You need to find the angle that's going to give you a tangent that's a positive 1. And you're going to use the same reference angle for the quadrant 3 possibility. Do you know what's going to give you a sine divided by cosine that's equal to 1? It's always the same 1. Do you know what your quadrant 1 possibility angle is? What is it? If you said pi over 4, you are correct. And then you're going to use that to figure out how much past pi this other one is. You might be thinking that this is 4 pi over 4 because that makes everything easier when you know that pi is the same thing as 4 pi over 4. And it's a pi over 4 past that. What is your fourth possible answer going to be? And then what I do is I take these two possible answers and I put them over here. And I have a solution set bracket that gives me all 4 possible answers for theta. And that's one of the reasons why I wrote the word usually. Usually there's 2 answers. There were 2 answers for this branch. There were 2 answers for this branch. So there were 4 answers total. That's how it's going to work. I'm going to stop your notes right there.